Hello guys, welcome back to Maths Zone African Motives. Still working on our mathematics N5, working on integration. This platform we shall be working with definite integrals, whereby we have integrals where you are supposed to apply our limits. So actually in a basic approach, what we just need in this case is to understand that if you are integrating a certain expression, let us take it as g prime of x dx. In this case, if we integrate g prime, it gives us gx with respect to x. We are going to obtain gx in this case, having our limits b and a, whereby we are representing our a in this case here as the lower limit in this case. So we are simply having this as the lower limit of our integration, our b being the upper limit of our integration. So what it simply means, after you've integrated your g prime x, it gave you gx, you are going now to substitute the limits, which is the b, which is the upper limit. So you're supposed to have it as the upper limit minus the lower limit in this case. So we are going to substitute in terms of the upper limit to the lower limit in this case. So meaning to say, in this case that we are having, in place of this part, we are going to have g of b minus g of a, whereby this is representing our upper limit. In place of x, we are substituting b every part. In place of x, we are substituting a in every part. That is, you subtract. So this we simply need to apply our integrals. That's it. We apply our limits. So there's nothing there about this part. You just need to know your basic integrals. If you have done your integrals properly, then this part is not going to be a challenge. So the first part, you're given to evaluate the definite integral of x minus 1 over the square root of x with limits 1 to 9. So all you need is just integrate this part. You substitute your limits in this case. Remember that if we are given to integrate this, we can separate. This is x minus 1 over the square root of x, which can be written as x over the square root of x minus 1 over the square root of x in this case, all right, with respect to x. Remember, if you are given a fraction with the one denominator, you can separate the numerator with that denominator. But here, knowing that from our laws of exponents, we are going to have the square root of x as x to the exponent of a half. So in this case, we are simply dividing x being divided to x to the exponent of a half, which is the square root of what? The square root of x. Knowing that if you are dividing and the bases are the same, you are going to subtract your exponents, which is 1 minus a half. So this is going to give us x to the exponent of a half. So meaning to say, by just simplifying this whole part, we are going to obtain at the end, we are going to have x to the exponent of a half. So this is going to give us, in this case, we are going to have the integral of, we've got our limits. So the whole part, we say it is going to give us x to the exponent of a half in this case. All right, which is the same thing on this part that we are having. We can simplify 1 over the square root of x. Remember, we said the square root of x simply means x to the exponent of a half. But the moment we are dealing with 1 over, we can take this on up, which is going to carry a negative exponent in this case. So this one is going to be written as minus x to the exponent of minus half in this case. So this is the only part that we are having integrated with respect to x. So we are supposed to integrate, then after that, we substitute our limits in this case. Remembering that if you integrate, we are simply adding 1 on our exponent. So this was going to give us, if we add a 1, this was going to give us x to the exponent of 3 over 2. Then we divide by the same exponent that we are having, which is 3 over 2. So this is same as 1 divided to 3 over 2. So if we divide 1 divided by 3 over 2, this is going to give us 2 over 3. So we have integrated. We are no longer writing the integration sign because we have already integrated here. So it's going to be 1 over, we divide this part. So we are going to remain with x to the exponent of 3 over 2 in this case, all right? So this is the integral of this part. We integrate also this part here. We add a 1 on our exponent. So that is going to be x to the exponent of minus a half plus 1. That's x to the exponent of a half over a half like this. We divide again 1 divided by a half. This is going to be a 2 in this case. So we're going to have minus 2x to the exponent of a half. So this is what we are obtaining after integrating. There's no need for us to apply the limits in this case because we understand plus c and minus c will cancel. So what you're going to do is that you work with it without the limits just as it is. I mean, without the c. But having our limits 9 and 1 in this case, these are our limits. So like I said, wherever there are limits, we are going to substitute the upper limit. In place of x, we are going to substitute 9. So it's going to be 2 over 3. Wherever there is x, we substitute 9 to the exponent of 3 over 2 minus 2. In place of x, we substitute 9 to the exponent of a half. So this is what we are obtaining from the first part in this case after substituting our upper limit. Minus, we substitute the lower limit. In place of x, we are substituting 1. So it's going to be 2 over 3 into 1 to the exponent of 3 over 2 minus 2 into, in place of x, we substitute a 1. So that's 1 to the exponent of 1 over 2 like this. So this is how you play around with your integral. So the only part that you simply need is to integrate direct the way that you are used. Then you apply your limit. So this whole part was going to give us 40 over 3. All right, so that is how we simplify our definite integrals. All we need is to integrate direct. After integrating, apply your limits, knowing that it's upper limit minus the lower limit. So we have another part here. Whenever we are given a trig, we evaluate the definite integral. This one, there is an application of a trig, and our limits is pi over 2 and pi over 3. In this condition, we are supposed to evaluate our everything, in this case, in radians. That is, our simplification is supposed to be taken in radians in this case. All right, so let us talk about the question that you're given. You're given the integral. We've got the limits pi over 2, pi over 3. This is x times the sine of x dx. So like I said, you go back to your normal integration. How do you integrate a product like this? We think of our by parts in this case, whereby we understand that from our by parts, the integral of f of x g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx. All right, so this is the formula that we have from our by parts concept, all right, whereby we need f of x from this information. So we can take our f of x to be x. So if we say our f of x is x, we are going to need its derivative, the first derivative of x, which is 1. All right, then the remaining part from this part definitely is going to represent g prime x dx, which is the remaining part, which is of sine x dx. So that means we've got our g prime x dx being equal to the sine of x dx. So this is going to give us gx. If we integrate both sides, we get gx in this case. Our gx is going to be the integral of sine. Remember, sine gives us a negative cos. Cos gave us a negative sine, so sine is going to give us a negative cos in this case. All right, so that's we are going to apply our by parts in this case. So this is equal to, from our by parts, we are saying we are going to obtain f of x by gx. This is equal to f of x by gx, which is f of x is x times our gx, which is negative cos x. So that's negative cos x. All right, minus the integral of f prime x. So our f prime x, that's a 1. So it's going to be 1 times gx in this case. Remember, our gx is negative cos x dx in this case. All right, so this is what you're going to have, having our limits, which is in this case pi over 2 and pi over 3. So that is how we apply our by parts concept. And as we can check inside, we are supposed to simplify. So we are going to have x times negative cos, which is negative x, the cosine of x. Then here inside, we've got a negative. We can take it outside to a negative there, which gives us a positive. So we're going to take it outside. So we've got the integral of cos x. So we're going to left with the integral of cos x with respect to x, and our limits being pi over 2 and pi over 3 in this case. So we understand that from our by parts, we are supposed to integrate. Again, here there's an integration inside. So we are supposed to integrate this part. So integrating cos, here we are going to have minus cos, minus x, the cos of x. Remember, cos gives us a sine. Remember, if we differentiate sine is cos. So the integral of a cos is a sine. So this one is going to give us the sine of x. And that's it with our limits, pi over 2 and pi over 3 in this case. So if we are to consider this part that we are having now, this is where we are supposed to go back to our limits. We have our upper limit and our lower limit. So in place of x, we substitute the upper limit first, and making sure that your calculator, in this case, if you're dealing with a trig, you're supposed to have your calculator in radians in this case. So that means we are going to have negative upper limit, which is pi over 2. So that's negative pi over 2. The cosine of x, which is pi over 2 in this case, plus the sine, our upper limit, which is pi over 2 in this case like this. So that's our upper limit minus the lower limit, which is pi over 3 in place of x. So we're going to have minus pi over 3, the cosine of pi over 3, plus the sine of x, which is the sine of pi over 3 like this. So that's upper limit minus the lower limit. In place of x, we are substituting our upper limit in this case. So this whole part, all right, let us save it on our calculator. Like I said, you're supposed to change your calculator into radians in this case. So that means we're going to have something like this. In this case, your calculator, if there's a D like this, it's in degrees. So you're supposed to change shift setup so that this gives us a rad at 4. So 4 here is giving our calculator now in radians. So the first part, just open a bracket, that's negative pi over 2. So we're going to have negative pi over 2 like this times the cosine. So we're going to have the cosine of pi over 2. So that's the cosine of pi over 2 like this. We close this part. This bracket is for the angle, all right? But we still have to add the sine. So there is a sine of pi over 2 there. That's sine pi over 2 in this case. We close the bracket for sine, but we're supposed to close that first bracket that we had in the first place, this one that we have. So we are going to close it at the end there. We are supposed to close again this bracket. So this whole part was going to give us a 1. This whole part that we will see is going to give us a 1. Minus, we simplify this part inside the bracket here. So in place of, we're just going to change where there is 2, we are just going to put a 3 because there is pi over 3. So we are just going to change where there's a 2. We are going to put a 3. We do the same. We move our comma, our part here. Okay. Where there's a 2 here, put a 3. Move again. Where there's a 2, we have to put a 3. So this was going to give us 0.342 in this case. So that's 0.342. So take note on your memo there. You have to check about if you are revising with this question, and we have this question paper. It's only that I don't forgotten actually the paper name, but it was actually a mistake there because this part here, if we simplify, it's 0.342, and this one is a 1. So we subtract now what we got from the first part, 1 minus 0.342 in this case. So this was going to give us at the end 0.658. So that's 0.658 at the end to 3 decimal places. So that's how we play around with this type of a question. You just need to integrate first. After integrating, apply your limits. On application of limits, it's always upper limit minus the lower limit. But the first part of your integration, it depends with what you're given. Maybe it's a trig, a straight trig, you just integrate. If it is a part that you're supposed to apply by parts, the concept there is you're supposed to know the basics part of your integration. After you've integrated, now you apply your limits in this case. So these are the typical questions that they will give you, just like this part again. We are given to evaluate the definite integral. So if we check here, we've got the square root of 9 squared minus x squared. Which integration are we going to apply in this case? If we check from our formula sheet, we are given the integral of the square roots, whereby we are given the integral of the square root of a squared, which is given as a squared minus x squared. If you check, we have got that this type of an integral, which is given as a squared over 2 arc sine. So this is arc sine of x over a. So it's arc sine of x over a plus x over 2 into the square root of a squared minus b minus x squared in this case, plus the constant of integration. That's how we integrate every type of this expression under the square root. So there are different types that you have to work with. Here we are given the square root of which 9 can be written in form of a squared. So it's the same as we are having in this case. It's same as we are having in this case. We are having our limit 0 and 1, and we've got the square root of a squared, which is 9. So 9, how do we write it in terms of a number raised to the power of 2? So 9 is same as 3 squared minus x squared dx. So as we can see here that this 3 is representing our a. So the 3 here is representing our a. This x is the same as the x squared here. So we are saying whenever we have got this type of a question, the integral of this part is going to be a squared over 2, of which our a squared, which is this part, a squared, which is 3 squared, which is simply 9 over 2. 3 squared, that's 9. All right, then we are going to have the arc sine of x over a. So it's arc sine of x over a. Our a is this, in this case, is the number raised to the exponent of 2. That is a squared. So our a there is 3. So it's going to be x over 3. This is what you're going to have. Plus x over 2. This part is going to remain as it is, x over 2. The square root of a squared minus x squared. So as you can see, a squared minus x squared is the part that we are having under the square root in this case, which is the square root of 3 squared minus x squared, of which is the same as this part that we had before. So it's going to be 9 minus x squared like this. All right, so that's how we integrate this whole part, but we do not need the constant. Since we have the limits in this case 1 and 0, there's no need for us to obtain or to use the constant. So that's it. We just need to know the basic integrals, how to integrate whatever that you're given. So in this case, we are back again, upper limit minus lower limit. In place of x, we are going to substitute 1 as our upper limit. Wherever there is an x, we are going to substitute 1. So we are going to have 9 over 2. This is going to be the arc sine of 1 over 3. So we've got the arc sine of 1 over 3 in this case, plus our x being 1, so it's 1 over 2, the square root of 9 minus 1 squared. 1 squared is 1, so it's going to be the square root of 9 minus 1, which is same as 1 squared, which does not affect. So that's our upper limit, minus the lower limit now, which is 0 in this case. So in place of x, we have to substitute a 0 in this case. So this is going to be 9 over 2 arc sine 0 divided by 3, that's arc sine 0 in this case. All right, plus, as we can check here, there's a 0 here. The moment we multiply anything by 0, it gives us a 0. So there's nothing that you're gonna have at the end here. All right, so if we are to simplify here, all we need now is our calculator. Simplify properly. So let us have our calculator. Also, since we are dealing with a trigonometry part here, there's a sign that we are dealing. Our calculator is supposed to be again in radians. All right, so the first part is going to be 9 over 2 in this case, arc sine, so that is shift sine 1 over 3, so that's arc sine 1 over 3 like this. All right, then we add plus 1 over 2, so this is going to be 1 over 2, the square root of, so we've got the square root of 9 squared, 9 minus 1, 9 minus 1 squared, which is 9 minus 1. We can put the square, does not affect, but close the bracket. Then we can have the answer for this one. So this one is going to give us 2,943, something like that. 2,943 to 3 decimal places. It's gonna be 2,943 in this case. Minus, we do the same thing. On the other hand, we are just going to substitute as 0 wherever there was our x, which is the way there's a 1 here. We are going to put a 0. Wherever there was a 1, we are going to put a 0 in this case. Wherever there is a 1, we are going to put a 0 like this. So our answer there is going to be a 0, meaning to say we are going to have 2,943 minus 0, which is equal to 2,943. 0.943. So that is the idea that you simply work with on the definite integrals. This is the introduction of your area. If you are talking about questions which are about area, they'll be it's actually calculating your definite integral. If you know this definite integral, then we are not going to have a challenge now if you are working with area, if you are working with the volume, because it's simply integrating, then substituting your limits, upper limit minus the lower limit. But there are some questions that you need to just play around again to understand, which is the application of the Laplace transforms. This part, I actually mentioned it on a separate part of the Laplace transforms, whereby you are given a statement which has got e to the exponent of minus st times f of t. This is the application of the introduction of a Laplace, where I say the Laplace of f of t in this case is given as the integral of, in this case, e to the exponent of minus st times f of t times dt like this. That's the Laplace of a function of f of t. It is going to be affected, this whole part, by f of t. So meaning to say, there's nothing that you're talking about. It's simply your integration, because this f of t, you just have to substitute like what we're given here. Our f of t is equal to minus 5. So what we simply need is to substitute minus 5 where there is f of t. So meaning to say this whole part is going to give us the integral of, we have got e to the exponent of minus st like this times our f of t, which is what? Minus 5. So whatever that you're going to obtain here, we multiply by minus 5 dt. That's the Laplace. So make sure that you watch the video on the Laplace concept so that you actually understand what you're talking about. Because I was saying, in this case, once you have got this is now back to you. It's now a normal integration that you're simply dealing with here, where we can simply take this 5 out of the integral because it's a constant. So it's minus 5, the integral of e to the exponent of minus st. All right, remember this is infinity here. That's an infinity there. So it's e to the exponent of minus st, which is left with respect to t. So you have to integrate the integral of e. Remember, if you're integrating e, is going to be e to the exponent of f of t over the first derivative of that function that you are given. If you are dealing with f of x, it's e to the exponent of f of x over the derivative of f of x. Here we are dealing with the f of t. So we are going to find the derivative there. So this is going to be minus 5. Then we integrate. So we said it's e to the exponent of minus st like this over the derivative of f of t. So we differentiate our function, which is minus st, where minus s is a constant. So we are going to obtain minus s like this. That means we have integrated, having our limits as what? 0 to infinity. So since we have got infinite, we are also supposed to know or to understand the laws of our limits in this case, all right? So you can take this one outside, the negative outside. This is same as 5 over 1. So negative, that's a positive. So we are going to obtain 5 over s in this case by e to the exponent of minus st, having our limits, which is infinity and 0. So this can be written as e to the exponent of minus is 1 over. So we are going to have this as 5 over s e to the exponent of minus st. We are just writing this in simplest form. Now we can have our limits because we are done integrating. Substitute upper limit minus lower limit, but knowing that we are dealing with an infinite, that is the only part. But everything, as you can see, it's a normal integration. So if we substitute infinity, e to the exponent of infinity, that's infinity in this case, we are going to have 5 over infinity minus the lower limit, which is a 0 in this case. If we substitute a 0 here, e to the exponent of 0, that's a 1. So we're going to have 5 over s, because s times 1, it's s. So it's going to be 5 over s in this case, all right? Knowing that here, 5 over infinity, remember from our infinity k over infinity is equal to 0. So we're going to obtain a 0 in this case. So that's 0 minus 5 over s, which is going to be minus 5 over s in this case. All right. So that is the application of the Laplace transforms. This is a Laplace transform that you are given. Is simply an application of integration, but still going back to our limits. So you need to know your integrals. you need to know your infinity limits, how to apply the infinity limits, and your basic integration, because everything here it's all about your integration techniques. So this is how it might be like. If you check, there is a question like this, which is another part which is important again, whereby they might give us integrals. All right, I'm supposed to have another question here. Let me put it this way. Let me put it this way, because this one, they do ask it this question here, whereby they'll ask you, given, you'll be given something like this, given f of 1 is equal to 3, f of 0 is equal to 1, like this, and you're asked to evaluate, then the question will be evaluate the integral of, we've got 1 and a 0 in this case, the first derivative of f of x times f of x, let's say to the exponent of 2 dx. All right, this is another question again on our definite integrals. All right, how do we play with this type of a question? This is an application whereby you are supposed to work with the change of limits in this case. If we are to take this information, they are simply saying if our value is 1, if we substitute value of 1, we get a 3. If x is 1, we substitute, we get a 3. If it is a 0, we get a 1, just like this part. There we have a 0 here. So if we substitute the 0, we obtain a 1. It's a change of limit. If we substitute 1, we get a 3. It's a change of limit to say, if whenever you change this expression here in terms of our f of x, we are going to also change our limits to 1 changing to 3 and 0 changing to 1 for that value that you be given. So how do we apply now our change of limits? Let us say we apply substitution method here to say let f of x, all right, okay, we can say let u be equal to our f of x, which is this function. Remember, if you are dealing with the substitution method, you take the complicated part, which is being raised to a certain exponent. So this is the part that you take. Maybe it's sine x. You say let u be equal to sine x. You find the derivative of u with respect to x, so that you are going to substitute because you're using substitution. So you need dx. So if we find the derivative of f of x, meaning to say that's f prime x. Remember, the derivative of a function means f prime x. Then we are supposed to make dx the subject. This is same as over 1, cross multiply. That means f prime x times dx is equal to du in this case. To find dx, divide by f prime x. So that means our dx is going to be du. So we're going to be left with the dx on this hand. All right, let me have it here, which is du over f prime x. So this is what is representing our dx in this case. Remember how you work with substitution method. So this is the part that I want you to be very clear with. If you're working with your substitution method, you're going to take this now as, from this whole process that we had, we are going to have this as in the integral of having our limits 1, 0 in this case, f prime x. We're going to have our f prime x by, remember we say this now, all right, this part that we see is f of x, which is now changed to u. We said let u be equal to f of x. The moment we introduce u, that is where our limits now are going to change to say, for the values of x that we have, our u is going to be 3 for 1. Our u is going to be 0 if x is 1. So meaning to say these limits that we see here, they are now affected. These limits that we are seeing here, they are now going to be affected since we are now substituting a u. So we are now going back to say, if our u, having our x being a 0 there, our u is going to be a 1. F of 0 is a 1. So meaning to say we are going to have 1 on the lower limit. If our x is a 1, the u, the corresponding part there as its limit, it is going to be a 3. So meaning to say this is what we are going to have. Since now we are substituting in place of what? F of x, we are now writing a u. So this is going to be u squared times our dx, whereby our dx, we say it's du over f prime x, like this. And I said this can actually cancel. This part and this part can cancel. We are left with the u squared. So this is a change of limits. the limits that are now affecting you, they are no longer affecting x. If we are to affect x, we're going to use x. We're going to go back to the unit of x, but we are now having a u. So we change also its limits in this case. That is the condition that we are given here. So it's a change of limits. From the limits that you have as 0, it gives a 1. On the other hand, 1 as a limit, it gives us 3 as the upper limit. So once you are at this stage, you are going to simply apply your normal integration in this case, because here we are left with the integral. These two, they cancelled, so we are left with the integral of u squared in this case with respect to u. That's it. We integrate u to the exponent of 3. Remember, on our integral, just add 1. So it is going to be u to the exponent of 3 over the new exponent, which is 3. Whatever that we are obtaining now, it's affected by these two limits. These are the limits that we are now using, which is 3 versus 1. So knowing our condition, that is going to be always the upper limit minus the lower limit. In this case, we are going to substitute our upper limit now as 3. So this is going to be 3 to the exponent of 3 over 3 minus our lower limit, which is 1 to the exponent of 3 over 3. So this is going to give us 9, the whole part, minus a third, and 9 minus a third is going to give us 26 over 3 in this case. So this whole part is going to be equal to 26 over 3. So that's how sometimes our integrals of these definite integrals might be like, whereby you need to change your limits. So the question, I expect these typical questions, they will just give you this information and they'll ask you to evaluate this. So you play around. That's a substitution that is you are taking place. From your substitution method, you take your u as the part that is complicated, the one that is raised to a certain exponent. That's the unknown value. So u is going to be f of x. The derivative of u with respect to x means you are supposed to differentiate f of x. How do you write the derivative of f of x? Is f prime x. That's what you're simply having, which is also there as on your integral. So you have to make dx the subject, substitute back your dx into this dx so that these two will cancel, you integrate, but not forgetting that the moment you introduce u in this case, you are supposed to take its corresponding limits. These were the limits of x. But now we are talking about u. It must have its own units. This is the change of what? The change of limits in this case. So it's an application of change of limits. All right, so that is how you're going to expect your questions to be like sometimes. So we just have to work with more questions, more revision, so that we get prepared for our exams, which are ahead.